today's video, we're going to learn how to read a set of rebar shop drawings. I'm going to briefly explain some of the general information about rebar, the process that leads up to receiving rebar shop drawings, and then walk through an actual example set of rebar shop drawings themselves. So let's go. Okay, so whether you're working on a residential or commercial construction project, you're likely going to have some sort of rebar, which is a structural element of your building footings, foundations, masonry walls, sidewalks, driveways, drive lanes, building slabs, or even precast concrete. Now, concrete provides high compressive strength, but is weak in tensile strength. Compressive strength refers to the material's ability to withstand forces that push down on it. Tensile strength refers to the ability to resist forces that would try to pull or stretch it apart. Rebar provides high tensile strength where concrete does not. So concrete is used in tandem with rebar to account for all the forces applied. The rebar requirements on a commercial construction project would be detailed and described in your structural set of drawings provided by a structural engineer. If you haven't yet watched my video on how to read structural drawings, that would be a better place to start before watching this video, so I'll drop a link to that in the description below. So when a contractor starts on a project in commercial construction, they owe a series of submittals to the design team. As it specifically relates to concrete scope, these submittals would include information on your concrete mix design and any additives, any accessories, which could be your vapor barriers, insulation, water stops, felt at expansion joints, joint sealants, release agents, but most importantly to this video, the rebar shop drawings. So the installing concrete contractor either has an individual who prepares these rebar shop drawings in-house, or more commonly, they hire another company to complete these rebar shop drawings. Rebar providers who furnish the rebar typically offer this design service. The individual who produces the rebar shop drawings would also have a structural engineering degree. This rebar designer reviews the structural set of construction documents, takes a look at the rebar size, spacing, location, quantity, and layout to produce their own set of rebar drawings for submission back to the structural engineer. The structural engineer reviews the rebar drawings for conformance with the construction documents that they produce, ideally stamps them as approved, and then you're able to release your rebar into fabrication. Now, when it comes to concrete slabs, there are other forms of reinforcement aside from your typical rebar that could be used instead, such as welded wire fabric or concrete fibers. Fiber reinforced concrete has small strands in the concrete made from steel, glass, or synthetic fibers. The requirements for each project all originate from the structural drawings and specifications in the construction documents. So the rebar gets onto the site, the field installers take those shop drawings and install the rebar according to those drawings. Individuals who bend or tie rebar on site are sometimes referred to as rodbusters and are typically ironworkers. So the rebar is installed, but before you pour concrete, you need to place any sleeves for piping that passes through any foundation walls, any anchor bolts or embed plates that support the steel, as well as your formwork that shapes the concrete as it's poured, typically formed by a carpenter. Now, formwork will come in a variety of types depending on the complexity of the project or the scope, which I'll make a separate video on in the future. Sometimes formwork is so complex that it requires its own set of shop drawings, but just know that formwork itself is not detailed in the construction documents. Now, just a little bit more information about rebar before we get into the actual drawings. So rebar comes in a variety of grades, examples being grade 40, grade 60, and grade 75. The grade corresponds to the strength of the bar. So grade 40 yields 40,000 pounds per square inch, or PSI, 60 is 60,000 pounds per square inch, and 75 is 75,000 pounds per square inch. Rebar also comes in different sizes, which is the corresponding diameter of the bar in eighths of an inch. So a number 3 bar is 3/8 of an inch in diameter. And a number 4 bar is 4/8 of an inch in diameter, or ½ inch when simplified. Number 8 rebar is 8/8 of an inch, which is the equivalent of 1 inch. Rebar can be fabricated uncoated, which is fairly typical in most scenarios. can be epoxy coated, which is an added protective layer to help prevent corrosion in some cases, and can also come as galvanized and even stainless. Let's quickly cover some accessories, tools, and rebar equipment that's commonly used. First, we have rebar chairs and slab bolsters, which come in different styles and heights. Rebar is typically placed a few inches inside the outside face of concrete, so that the rebar itself is not exposed to further corrosion from the elements. So you need something to keep the rebar off the ground that will hold it in place when it's poured. Speed dowels are used to adjoin two separate slabs, not often used in commercial construction, but more commonly found in residential slab-on-grade pours. Then we have rebar ties and tying tools. Rebar needs to hold its form as it's getting loaded with concrete. So Rodbusters or Ironworkers will use spools of wire to hold the rebar in place and tie it together using an old school tie wire twister or more commonly used automatic rebar tying tools. Okay, let's jump into our set of drawings. So if you recall from my structural drawing review video, we actually reviewed this structural page S-1.1. On this page, we have a schedule that details the extent of reinforcement based on footings, walls, and piers. On a couple other pages in the structural drawing review set, we looked at more in-depth details that our rebar shop drawing designer will also capture. So again, the rebar designer took this baseline information from the structural construction documents and drew a set of shop drawings, which I have here. This shop drawing set has 3 pages to help convey all the information that we'll need. Now, I have to mention that shop drawings for rebar often vary on how they look, how the details are presented, because it's an individual designing it. So there's no overall industry-wide standard layout. So this is more of a reference guide on how to go about reading these in general. So moving to our first page is our foundation plan view, which we have a couple section cuts as well, but most importantly, all the abbreviated notes that we'll get back to later on in this video. It also has a chart for reference on the right side, which I'll get to in just a minute. On our second page, we have more in-depth section cuts of our different areas of the foundation. Then on our last page, we have all of our rebar members, which I'll go through this in depth. So jumping back to our first page, I'm going to zoom in on our reinforcement notes. So starting at the top, B stands for bars in the bottom, meaning the bars are placed in the bottom portion of the pour. Then B1 is our bottom or our lowest layer of reinforcement. B2 and B3 are our next 2 lowest layers of reinforcement. Then T stands for bars in the top or the top portion of our pour. T1 is our uppermost layer of reinforcement. T2 and T3 would then be the next highest layers of reinforcement below T1. EF stands for the number of bars in each face, NF are the bars in the near face, and FF are the bars in the far face. Then we get into some additional bar notation with AR, alternately reversed, AS, alternately staggered. We have U bars, L bars, UBC, UBH, and finally V for vertical. I'll reference back to these to make more sense of these notations as we dig further into this rebar set later on in this video. So moving over, we have our foundation plan. Highlighted here, we see callouts that we saw on our structural drawing set, such as WF1, F1, F4, F5, and P2, among many more. So the WF1 are our continuous concrete wall footings. F1, F4, and F5 are additional larger footings. And then P2, this is an example of a concrete pier. These drawings are also dimensioned, which help us picture the size and the length of these footings. Looking closer at this WF1 continuous footing, there is this note 3-5-56-B. So what does this mean? Well, this is actually fairly standard rebar notation that you should find on most sets of rebar shop drawings. and this one is specific to the WF1 continuous footing. The number 3 stands for the quantity of bars. The number 5 stands for the size of the bar. So if you recall, this 5 would mean that the rebar is 5/8 inch in diameter. The number 56 is our piece mark. So this is how we would identify this piece of rebar on our chart. And then finally, the B stands for bottom, or the placement of this rebar. Now, if I wanted to see what this WF1 footing looked like in section view, I would just scan this rebar shop drawing and find a section cut with the WF1 footing. Now, this is a section cut, but this is a WF2, so we wouldn't use this section cut H because it's likely a different detail with different rebar. So if I continue along this drawing, I find the section cut G, which is in a WF1 footing. Now I'm going to look for this section cut G, which happens to be on the same page. So we see our quantity being 3 number 5 rebar in the bottom of this footing, which matches that bar notation we just talked about. This also shows us the overall size of the footing, which is 2 foot 6 inches wide by 1 foot tall. There are notes 3-inch cover and 2-inch cover, which references the concrete coverage on each side of the bar. So there should be 2 inches of concrete cover on each side and 3 inches on the bottom of this WF1 footing. So with this footing being poured directly on the ground, this is where we'd utilize some sort of chair or stand to elevate that rebar off the ground to get the proper concrete coverage in this footing. Now, I mentioned the rebar notation on this drawing previously, the 3 number 5-56-B. So that 56 was indicated as the piece mark. So I'm going to flip over to our rebar schedule to explain this. Okay, this page references all the different types of rebar on this project. There are member types, which relate back to those reference notes I ran through earlier. The mark, which is the piece mark I just mentioned as 56 in this example, the diameter of that bar, the total number of members, the bars in each member, the total number of bars, and the shape of that rebar itself. So right at the top, I see WF1, which does match our footing, but it's a different diameter bar. See this number 6? We had number 5 in the example that we were previously looking at. So there are multiple WF1s on this project and in this drawing set. So instead of looking for WF1, we're simply going to find our piece mark. So if I scroll down, I get to the 56 piece mark. So if I look at this entire row, I see that the member is B, which matches for bottom. The bar diameter is 5, and the total number of bars is 3. And then finally, the footing is WF1. So we found the right spot. Finally, if I wanted to just do a triple check, I can always measure the length of the bar and match to the drawings. So on this page, I show 33 feet 9 inches. And if I flip back to that section that we were looking at for the WF1, it matches. So this is a fairly simple example of how to read and navigate through rebar shop drawings based on a simple footing. Now I'm going to flip into the model of this to briefly show you what this looks like in 3D. So once I zoom in, we can see the rebar in this WF1 footing in red. The box out is the actual concrete that would be poured around it. How about we take a look at this footing in pier, which is slightly more complex. So flipping back to our foundation plan view, we see that this aligns with the F5 footing and the P5 pier. Now that we know this footing and pier designation, let's dig into this a little further. I'm going to take a look for more information about these on our details page. So I'm actually going to flip to the next page. Okay, zooming in on this page, we found our F5 and our P5 detail. And this is a plan view, meaning that we're looking down at the rebar from above. And similar to our WF1 footing, we have all kinds of bar descriptions listed in further detail. We also have an additional section cut F. So I'm going to slide this over so that we can see both the plan view and the section cut view side by side. So we see the bottom portion is our F5, which is our footing, and the top portion is our P5, which is our pier. Looking back at our plan view detail, let's start with the rebar in our F5 footing, which is the larger rectangle. We have 4 bar notations, which mean 4 different types of rebar that make up this footing. There is 8-6-16-B2, and then we have 8-6-16-T2, and then there is 8-6-09-T1, and finally we have 8-6-09-B1. So let's go check these out on our bar chart or our bar schedule on the next page. Okay, we found our piece numbers 09 and 16, which is associated to our F5 footing. We see all 4 bar types that were notated on the previous page. And then look at the shape of these bars. Notice the difference from our straight rebar that we found in the WF1 footing. The next thing I want to reference back to is the member. So we see B1, T1, B2, and T2. Now, if we recall and reference back to what these mean on that first page, we can figure out a little bit more of how these stack together in our F5 footing. So B1 is our bottommost layer. Then 1 layer up is our B2 layer. Above that is our T2. And then finally, our uppermost layer of rebar in this footing is T1. I'm going to pull up the plan view and section cut to show how this looks on a drawing. Okay, so we have our B1 bar, which is our piece mark 09 on the very bottom layer here. Then above that, we have our B2 bar, which is our piece mark 16 directly above our B1 bar. Next, we have our T2 bar, which is also piece mark 16, but differentiated from the member type. We see that in the second to top layer here. And then finally, we have our T1, which is also piece mark number 9 in our uppermost layer. Now, while looking at this, I want to point out that our plan view looks like it only calls out 1 bar at each of these locations, and that's just because there's not enough space to detail out every bar on the plan view. So as a reminder, the first number in this bar sequence is the quantity of bars. These lines indicate that the bars run from this point to this point along the line. So in our section cut for B1, we can count out 8 bars on the bottom. Also in our section cut for T1, we can count out 8 bars on the top. Now, if I were to overlay these B1 and T1 bars on the plan view, it would look like this for B1, and it would look like this for T1. Now, the section cut also shows that there are B2 and T2 bars, but since the section cut is slicing left to right, we only see the 8 bars for B1 and T1. If the section cut were the other way, we'd see all 8 of those B2 and T2 bars, but we still know that they're there based on the bar designation. If I were to overlay the B2 bars, it would look like this. And finally, if I were to overlay the T2 bars, it would look like this. So let's jump into our model and see how this would look like in the field as it relates to the plan view and section cut view. Okay, so here I have highlighted the B1 bars at the very bottom. Then I have the T1 bars at the very top. Next, we have the B2 bars, second from the bottom. And finally, we see the T2 bars, second from the top. We see the shapes of all these bars match what we saw on our bar chart. So after reading the rebar shop drawings, this is essentially how the field installer would be expected to tie these bars together for the F5 foundation. All right, let's move on to our pier, which is our P5 notation back on the previous page. Okay, so we're looking at the remainder of designations for rebar on the P5 pier, and we have the following bar designations: 5-6-01-V, and then 4-6-01-V. And then we get a repeat of 5-6-01-V, and yet again another repeat of 4-6-01-V. And finally, we have this 5-4-31-links. Now let's go to our bar schedule to find this P5 and these corresponding members. So looking at the V members, we see a total of 18 bars. And if I pull up a plan view next to this, we can see and count 5 + 5 + 4 + 4, which gets us to that 18. Now, also, let's take a note of the shape of these bars. All right, jumping out of our bar schedule and jumping back to our section cut of our pier, I see this 01 piece mark noted here, which corresponds with the bar members that we're just looking at and the general layout on our plan view. Let's see what these look like in our 3D model. Okay, so here we have our 5-6-01-V rebar. Moving on to the next surface, we have 4-6-01-V. And if I continue to spin the model, we get back to our 5-6-01-V rebar. And our final turn, we have our last 4-6-01-V, just to give you some perspective of how this rebar all comes together. The last pieces of rebar that we have on this model are our links, which hold this whole pier together. And if you recall, we had 5-4-31-links from our drawing, which reflects here in this model. Now, flipping back to the section cut, we see the corresponding 31 piece mark called out for our links, with a general layout of the pier. Now, the model showed a little bit more clarity to the location and the spacing of this links. So if there were any question on how these needed to be incorporated or installed, I would just reach out and ask the question from the individual who put together these shop drawings. So the final thing I'll note here is that there are also anchor bolts and embed plates, if you recall from my structural review video, supporting the structural steel above, which will need to get installed alongside the rebar prior to pouring concrete. Steel fabricators will put together their own set of shop drawings showing the placement of these that we would need to reference alongside these rebar shop drawings. Okay, that is our broad overview of reading and digesting rebar shop drawings. You should now be better equipped to understand your own set of rebar shop drawings on a project and how you come to get a set of rebar shop drawings. Now, if you enjoyed this video, let me know in the comment section below. Also, if you're looking to expand your knowledge of construction in general, hit that subscribe button and I'll continue to cover lessons just like this on other topics. And as always, be better, build better, and bye for now.